last last class I have discussed uh, up to table number 2. You see table number 2 you see up to discuss. So in table number 2, here one delta J is positive. It's okay, Argus?
Yes, sir.
Okay. So you see here in table number 2, in delta J value, which delta J value is positive? Here you see 1 by 2 is positive. So 1 by 2 is our incoming vector. So minimum ratio will be xb by y1. Okay, xb divided by y1. So same as first ratio will be 10 by. You see the table number 2. First, in minimum ratio, how to find out? XB is 10 divided by uh, X, XB by yes 10. Then minimum ratio will be how to find out XB by Y1. Okay. So XB by Y1 will be 5 by 2. So ultimately we get this one will be 4. And next one, second ratio will be 3 by minus 1 by 2. So ultimately answer will come in the minimum ratio negative value, so we will not write. And third ratio also 1 by minus 5 by 2, so also negative. Okay, so we will not consider the second and third row minimum ratio. So here only 4 is minimum. Okay, so first row, S1 row is our minimum ratio row. Okay, so here our pivot element will be intersection of incoming vector and minimum ratio row. Incoming vector is also called the key column. Okay, and minimum ratio row is also called the key row. Okay, so here 5 by 2 is our pivot element or key element. So I have marked here 5 by 2. So this is clear. Sonali, table 2, Keshav, Keshav
Yes,
present
sir.
or not?
Yes, sir.
So next one you see, next here we find out the new table. Third table you see. So in the third table, so here which one will be outgoing? Which variable will be out? Ishita, which variable will be out? From
So
second table
S1,
to third, S1. S1 will be out and this S1 will be replaced by incoming vector Y1. So you see in the third table you see y1 in the basic variable I have written y1. So coefficient of y1 is -1. So in CB I have written -1. Y2 remains same. So in CB y2 value is 3 and S3 is 0. Okay. So in the third table, how to write the first row? So you see our pivot element is 5 by 2. So our pivot element is 5 by 2. So each element of the minimum ratio row is divided by 5 by 2. So 10 divided by 5 by 2, then we write in the third table. So this is 4. Next one is 5 by 2 by 5 by 2 is 1. Next 0 divided by 5 by 2 is 0. 2 divided by 5 by 2 is 4 by 5. 1 divided by 5 by 2 is 2 by 5. 1 by 4 divided by 5 by 2 is 1 by 10, and 0 divided by 5 by 2 is 0. Clear? So, in the third table, how to find out the second row? Okay, so how to calculate the element 3 in the third table? In the second table, 3. In the second row, second table, 3 element, how to replace? Okay, so how to replace? Arbas, how to write?
Sir, can you please repeat your question?
How to write 3 minus 3 minus minus 1 by 2 into 10 divided by 5 by 2. So ultimately we get 5. Now I am audible. It's okay?
Yes, sir, you are.
Okay. So next one will be, you see, our outgoing vector in the column is S1 is the outgoing vector. So S1 element will be placed in Y1, incoming vector means Y1. So Y1 element will be like 1 0 0. So I have written 1. Okay, 1 0 0. So 0. Next you see Y2 column. In Y2 column and second row, how to replace 1 in table 3? So 1 minus 1 by 2 into 0 divided by 5 by 2. So ultimately 1. Next, in Y3 column and Y2 row, second row, Y3 column, so how to replace 0? 0 minus 1 by 2 into 2 divided by 5 by 2. So this is we get 2 by 5. Similarly again 0 minus 1 by 2 into 1 divided by 5, 1 by 5. And 1 by 4 minus 1 by 2 into 1 by 4 divided by 5 by 2. So 3 by 10, and next 0 minus 1 by 2 into 0 divided by 5 by 2. Means what? Here you see, in the second table, first row is our minimum ratio row. So with respect to the first row, we calculate when we calculate the second row and third row in the new table, we compare with the first row. Okay, so second row in this way calculate. Third row, 1 is replaced by, how to replace 1? 1 is replaced by 1 minus 5 by 2 into 1 minus 5 by 2 into 10 divided by 5 by 2. So 11. Next one is 0 automatically. Next 0 element is 0 minus 5 by 2 into 0 divided by 5 by, so 0. Next 8 minus 5 by 2 into 2 divided by 5 by 2, so this is 10. Next 0 minus 5 by 2 into 1 divided by 5 by 2, and this is 1. Then minus 3 by 4 into minus 5 by 2, 1 by 4 into 1 by 4 divided by 5 by 2, then you will get minus 1 by 2, and 1 minus 5 by 2 into 0 divided by 5 by, same as earlier. So in the third table you see, in table number 3 you see, z dash equal to we get 11, delta j value is 0, next value is again 0, and next value is minus 12 by 5, next value is minus 1 by 5, next value is 4 by 5, minus 4 by 5, then 0. And this delta j can be calculated same as earlier. Delta j equal to Cj minus Cb into Yj, same as earlier. Okay. So from third table, can we get the optimal solution?
Yes, sir.
Yes, we get an optimal solution. So why we get an optimal solution?
Because all the values are less than 0, are negative or 0.
So like delta J values are less than or equals to zero. That's why.
Yes, all delta j less than or equal to 0. Okay. Commodus, clear this one? When we get an optimal solution,
Yes, sir.
Anuj,
So like all
then
delta J values as in like only the y1, y2
not,
and y3 columns, ne? Right?
your voice is not clear, Arbas.
Sir? So I said that like all the like delta J values which has to be like less than equals to zero, like those are only the y1, y2 and y3 column, right? Sir, can you hear me?
My voice is clear. Arbas, your voice is not clear.
Oh, so like, can you hear me now?
Yes, sir. Anybody
Yes, sir.
or Roshni?
Yes, sir, your voice is audible now.
Voice is not clear. Why?
Sir, can you hear me now?
Okay, some network issue maybe. You see, here table number 3, so all delta j value is less than or equal to 0. So we get an optimal solution. So I have written here, you see, since all delta j for all non-basic variables are negative, so this solution is optimal. Or you can write shortly, since all delta j less than or equal to 0, so we get an optimal solution. And optimal solution is what? So here you see, show me anything.
Sorry, sir, by mistake.
So you see, here optimal solution is y1. So y1 represent the variable x1. So x1 equal to 4. So x2 equal to 5. And what is the value of x3? What is the
Sir,
value of
11.
x3? Yes, Arbas? Anybody?
So like I thought it was 11, but like you have written 0, so like I'm confused right now.
Acha, you are confused. From your view, 11. Okay. Roshni, what is the value of x3? X x3.
Sir, 0.
Ishita?
Sir, no idea.
Acha, here in the given problem, what are the variables? What are the variables in the given problem? Variables are what? In original problem. ओरिजिनल
Sir, like
प्रॉब्लम में क्या वेरिएबल क्या
x1,
क्या है वो
x2, x3.
x1
X.
x2 x3 variables are x1 x2 x3 so after solving this we need the value of x1 x2 x3 okay so y1 represent the value of x1 so x1 equal to 4 y2 represent the variable x2 so this is the value of x2 so x2 equal to 5 and here you see there is no x3 no x3 so x3 value will be 0 not 11 this is the value of s3 11 is the value of s3 and x3 is absent here means y3 is not present so x3 is not present here so this will be x3 is equal to 0 and next one you see after solving this is the problem we convert this problem in maximization so z dash gives us the maximization value means you see min z equal to minus z dash so z dash value is 11 so minus 11 because you see first, we convert it into the maximization, minimization to maximization. When we solve this table, then this is the problem of maximization table. Okay, but our given problem is minimization. So when we write minimization, again we write this is mean z equal to minus z dash. So z dash value is 11, so minus 11. So you see this is clear or not? Arbaj, everyone,
Yes, sir. It does.
Yes, sir.
okay? Yes, Nihal.
Yes, sir. It's clear.
Then Shudip.
Yes, sir. Clear.
So you see, here we know because in your exam, either problem will be asked in your exam problem may be either minimization problem or maximization problem. Maximization problem, then okay, but minimization problem, then first you convert it into the maximization and same procedure. And finally just you convert it into the minimization. Okay, so here you see in the first page I have written inside note min z equal to minus max into minus z so minus max z dash actually relation is this one so max z dash equal to minus min z or min z equal to minus max z dash here you can write either dash or star anything you use okay so here sometime ask question how to convert one maximization problem into minimization problem then you will write this one maximization problem means minimization problem can be converted to maximization problem by this min z equal to minus or yes my min z equal to minus max z dash. So and another thing you will remember tie up maximum delta j value is tie up then there is no rule or formula arbitrarily you choose the incoming vector because maximum delta j gives us the incoming vector So here you can choose any one. Okay, arbitrarily you can choose, because in first table you see, first table delta j value is -1. You go to the first table, delta j value is -1, 3, -2, 0, 0, 0. Suppose -1, 3, again in place of -2, again 3 is present, then your question may arise, which column we consider the incoming vector. Then you choose arbitrarily either y2 or y3. So what happen, if you consider y2, then sometime after 3 table you will get the solution, and someone consider y3 is our incoming vector, then after 4 table will get the optimal solution. There is actually, these are called the iteration method. Okay, so this is clear, everyone?
Yes, sir.
Sir.
But you see, minimum ratio is tie up. Suppose sometime what happen, next class I shall give, if minimum ratio is tie up, then what we do, if minimum ratio is tie up, then you will not choose arbitrarily any one. Then there is some formula, with the help of this formula we consider the minimum ratio. So everyone, you will do practice. Okay, means I have given the form how to find the from old table to new table element, how to find out. You will just do practice, then it will be clear for you. Abhilasha, clear up to
Yes,
this?
sir.
Okay.
Yes, sir.
Abhishek.